Hello everyone, welcome back to our geometry class. Today we are going to talk about the last topic in this unit, which is called sector area, which is actually very similar to the one we had before about arc length. So before we talk about the formulas we are going to use to find sector area, we are going to introduce the first concept, which is sector. So what is a sector? As you can see, this shaded region here is actually an example of sector. So as you can see, sector is formed by two radii and also concluded by one piece of the arc. Then the region concluded by these three parts is actually called sector. One thing I want to remind you is sometimes it's very easy to be confused with for example, I have this piece, but if we just shaded the top part, it's like, I taking off this, triangle spaces here, then this area, this, the shaded part is not a sector, which is actually have different name. So that's why the sector is actually more like a fan, like this kind of region here, or sometimes you can see this in the baseball field, or sometimes you can see this kind of shape in the garden area. So this is called a sector. And next part, we are going to see quick examples here about the sector area, which you actually saw this kind of picture in the arc length. But remember, arc length, we only care about this edge, like, the distance around the arc. But sector area, we're talking about edge or space shaded in this part. So this is sector area. For example, you want to design the baseball field, you need to figure out how big for this field, then this area is actually sector area. Same thing. For example, I want to cover the whole, I want to design the whole artifact, but I need to figure out how much material for me to use cover the whole thing. Then the whole area, remember, is always covered the bottom part, then this is sector area. Okay, so very similar to the arc length, we also have two ways to figure out the sector area. But before that, there's a very important concept for us to review, which is the area of the circle. We all know area of the circle, which actually is strongly related to the r, which is pi r squared. Do not forget the square part, which is actually whenever we talk about the area, remember the unit is always inches square, centimeter square, meter square. So do not forget the r square is pi r square. And we always know the relation between r and between the radius and diameter, which is the half of diameter with the radius. So we can also rewrite this as half of the diameter square. So either way you can use it, but since we don't need to deal with fraction in using r, using radius in finding the area, so most of the time we just prefer to find the radius first, and then we use the area formula. Okay, you may wonder, why do I have to use excuse me, why do I have to use area formula in this situation? Because in sector area, as you can see, the formula is actually related to the area of the circle. Let's see what is the structure of this formula. So sector area, we actually going to use the central angle here. As you can see, central angle is always same as arc mirror. So you can always, replace this as arc mirror if you do know the measurement of this. So the structure is actually telling us we need to figure out how much central angle into the whole circle, what's a percentage for central angle into the whole circle, 360 degrees. And then we time this ratio to the whole circle area, then that ratio times the whole circle area, which is sector area. So it's kind of, for example, this is a piece of pie. We just need to figure out how much this piece of pie get into the whole circle. Then we use central angle divided by 360 to find out this ratio. Then this ratio times the whole circle area, then that will be your sector area. Okay, so that's one way. Then very similar to arc length, another one is actually a proportion. We set up the two ratios. So as you can see, we consider the ratio between central angle to the whole circle, which is 360 degree, same as the ratio between sector area to compare to the whole circle area. So that's why since the ratio is actually equivalent, so that's why we can set up the proportion like that way. So that's another way to find it. As you can see, the first method here, if we are looking for a sector area, this is very straightforward, right? We can just plug in the value we know into the formula and figure out the answer. But for the second one, it will be useful sometimes if we're looking for, if we know the sector area, but sometimes we have to look for either radius or even central angle measurement, then in that case, that one, it will be more helpful. So that's just, two ways to do it. But trust me, whenever, no matter which one you use to solve the question, as long as you set up equation correctly, substitute the value correctly, then you will get the right answer and you will get the same answer. So to totally master this method, we are going to practice 3 examples in the next video, so you can be more familiar with this process and you know how to solve this kind of related question by using either the first method or the second method. Okay, again, thank you so much for watching this video, studying this topic with me. I will see you very soon in the second video.